Alright, so we already talked about distance and midpoint, and now we're going to use midpoint a little bit further, and we're going to look at what happens when I do have the midpoint, and how do I find that other endpoint. So there's I got about 4 examples for you today to look through. So if you know B is between A and C, and AB is this, BC is this, is B a midpoint? So what it's asking now is not find the midpoint, it's asking, can I prove that it is a midpoint? So we've got point A over here, point B in the middle, and I'm always going to draw it as close to the middle as I can, because if it is a midpoint, we want it to be there, but it's a little bit easier to visualize when we have it there. It's hard to read. And BC is 6x minus 2. And the entire thing is 21. Okay, so what I can do is I could go through and I could find x just like I have in the past, where I take the 2 segments and I add them up to 21. Take our 3x plus 5, add it to our 6x minus 2, combine like terms, you got 9x plus 3 equals 21. So we get x is 2. And what I'm going to do now is I'm going to plug 2 back into each of these, because the question's not asking just find x or find a segment. It wants to know, is it a midpoint? So when I plug 2 back in right here, 3 times 2 is 6, plus 5 is 11. 6 times 2 is 12, minus 2 is 10. They do in fact add up to 21 because we set it to do that, but 11 and 10 are not equal. So B is not a midpoint. Take a minute and think about what would these have to be for them to be a midpoint. Well, if the entire segment's 21, each one of these would have to be 10 and a half. Since they would be 10 and a half, I could work backwards from there to find x that way as well. Example 2, EC, you have to be 2x plus 8. You have CF to be 8x minus 4. C is the midpoint of EF. What value of x makes that true? Well, if it's a midpoint, we know that this is congruent to this. So let's make them congruent. Congruent segments have congruent or have equal measurements. Get the x's together. Move the 4 over. Divide by 2, get x is 2. So if I were to have x to be 2, 2 times 2 is 4, plus 8 gets us 12. 2 times 8 is 16, minus 4 is 12. Since they're the same, C is a midpoint. Here's one that you just want to think about. We don't even need to really draw a picture. If D is the midpoint of AB, and AD is 12, what's the length of AB? And I know I said I don't need to draw a picture. I'm going to anyway. There's our line. We have AB, and we have point D in the middle. And it says AD is 12. Since it's a midpoint, I know that this is 12 also. 12 plus 12 gets you 24. Now, here's the different thing we have that I'm going to show you 2 different ways to do this. And I think the second one you're going to find to be a little bit easier. So you're given the midpoint. Whenever you're given this point M, it's always the midpoint of AB. And you have one endpoint, and then you have point B, which we're just going to call XY. I don't know what it is yet, but I'm going to find it. And the way I'm going to do this is I'm actually going to break apart the x's and the y's separate. I'm going to look at just finding x first, and I'm going to call this x1, y1. Alright, and this is going to be xm and ym. I'm using m because it's the midpoint. So we had our midpoint formula. Let me put this up here in blue. And what we're able to do with this is we can take each individual fraction here and put it in an equation with our midpoint. So we have x1 plus x2, which we don't know yet, over 2 is equal to my midpoint, 6. Then for y, we have y1 negative 4 plus y over 2, and that's equal to my negative 10. Now you go through and you solve each of these. You got to multiply both sides. Let me switch colors for a second. Multiply by 2. When you multiply by 2 on this side, those go away. Subtract 2, get x is 10. Over here, multiply by that denominator again. I'm going to add 4 to both sides here and get y is negative 16. So take those two together. My value for point B is 10 negative 16. So what you're doing is you're trying to find a point that is halfway between A and 10 negative 16, and we get 6 negative 10. Let's look at this a different way now. So I have a new problem, almost the exact same setup. The only difference, we have R being the midpoint. I'm not sure why, so let's just go ahead and change that to M. So it's very similar. And we know that A, B are on the outside. So if I were to draw these in order, we'd have A, then we'd go down to M, then we'd go down to B, where M is halfway in between. Alright, point A, we don't know yet. Point M is 4, negative 7. Oh, that looks like a 2. And point B is 6, negative 3. So what we're going to do is we're going to look at, since I know M is in the middle, it's exactly in the middle, meaning the change from one point to the other is the same. So ask yourself, how do I get from 6 to 4? Well, I subtract 2. So to get from 4 to this point, I also subtract 2. 4 minus 2 gets me a value of 2. How do I get from negative 3 to negative 7? I have to subtract 4. So I also have to subtract 4 here. Negative 7 minus 4 is negative 11. So our answer is 2, negative 11. Now, I went through that kind of quick. What we're looking for is the same rate of change, because I know that this x value, this 4, is halfway between 2 and 6. I know that this negative 7 is halfway between negative 3 and negative 11.